Ever wondered why an apple falls from a tree, but a feather flutters down gently? The answer lies in a fundamental principle of physics, Newton's second law of motion. This law states that the force acting on an object equals the mass of the object times its acceleration. In essence, the heavier the object and the faster it's going, the more force it exerts. But how did Sir Isaac Newton, a 17th century physicist, come up with this law? Well, he was a curious observer of the world around him. He noticed the way objects moved, and by conducting a series of careful experiments, he was able to formulate his second law of motion. His findings were published in his seminal work, Philosophiae Naturalis Principia Mathematica, which laid the groundwork for the field of classical mechanics. Now, let's break down this law a bit further. Force equals mass times acceleration. It's a straightforward formula, but it has far-reaching implications for understanding the world around us. It tells us how objects will move based on the forces acting upon them. And this law isn't just theoretical, it's very much a part of our everyday world. It's why a rocket can launch into space. The force produced by the burning fuel is enough to overcome the mass of the rocket and the pull of Earth's gravity. It's why your car moves smoothly along the road. The force of the engine is balanced with the mass of the car and the friction of the road. So the next time you see a rocket soaring into the sky, remember Newton's second law, F equals m times a. It's a simple equation, but it's one that has helped us understand the movement of everything from the smallest particles to the largest planets. And it continues to be a cornerstone of physics, guiding our exploration of the universe. As we continue to push the boundaries of our knowledge, we can thank Sir Isaac Newton for giving us a fundamental tool to understand the world. Have you ever noticed how a swimmer pushes the water backward to move forward? This is a classic example of Newton's third law in action. Let's take a trip back in time. When Sir Isaac Newton was formulating his third law, he observed that forces always come in pairs. Every action triggers a reaction, and these two forces are equal in magnitude and opposite in direction. This observation became the cornerstone of Newton's third law. Imagine a horse pulling a cart. The horse exerts a force on the ground, and in return the ground exerts an equal and opposite force that propels the horse and cart forward. It's as if nature is saying, "You push me and I'll push you right back." Quite a tit-for-tat arrangement, isn't it? But Newton's third law isn't just about horses and carts, it's everywhere. When you jump off a boat, you push the boat backwards as it propels you forwards. When a bird flaps its wings downwards, the air pushes the bird upwards. Even the beating of your heart uses this law, with each contraction sending blood rushing through your veins. And what about those magnificent rockets that shoot up into space? They're perfect examples of Newton's third law in action. As the rocket fuel is ejected downwards with a great force, an equal and opposite force propels the rocket upwards, defying the pull of Earth's gravity. This law doesn't just apply to moving objects, it's also at work when you're sitting in a chair. Your body pushes down on the chair with a force equal to your weight, and the chair pushes back up with an equal force. That's why you're not falling through the chair right now. So, there you have it. Newton's third law is not just some abstract concept. It's a fundamental principle that governs our daily lives and the functioning of the universe. It's in the push and pull, the give and take, the action and reaction. So, as you walk, run, or simply push a door, remember, for every action there is an equal and opposite reaction. That's Newton's third law for you.